Good morning, class. Today we're going to look at lesson number 14, and this is the effects that the recent changes in Earth's climate has had. So I want to start off by looking at the effects that the changing climate has on ocean life. So one of the biggest effects that this change has had has been on phytoplankton. So the global population of phytoplankton is decreasing at about 1% a year. And that may not seem like a lot, but just to give you a scale of things, that we've been working most of this course on scales of thousands of years. So if this trend keeps continuing, the population is going to disappear um, within like 500, 600 years. So at 1%, it's not like you go from 98 to 99 or 99 to 98 to 97, and then from like down to 1 down to 0. Because like 1% of the population, as this population gets smaller, you lose a smaller percent. So it would take more than 100 years. But after 1,000 years of decreasing every year, uh, the population is just going to be gone. And these phytoplankton are the bedrock of the food web, or like the food system, the food chain, um, in ocean life. So without phytoplankton, things just don't work in the ocean. So let's dig into some of the science here. So a couple things that are affecting phytoplankton are pollutants in the oceans, as well as increase in ocean temperatures. And it's actually found that increase in ocean temperatures has the largest effect. So pollutants in the water are not great for anybody, but they're not the leading cause of why the population is decreasing for these phytoplankton. So we've also found that not only is the population decreasing, but the productivity of these phytoplankton, how much energy they produce, is decreasing as well. So if we look at the graph below, and if we look at the blue line, or sorry, let's look at the red line first. So that red line, that's going to relate to the right y-axis. So the one where the mouse is going up and down right now. So this is going to be the temperature, how the temperature is changing in the ocean based on the average temperature over the last about 20 years, maybe 25 years. So they just take that average temperature and they compare how the ocean temperature changes. And we've noticed that it's not been a set increase in the ocean temperature. The ocean temperature does fluctuate. And as the ocean temperature fluctuates, the productivity of these phytoplankton fluctuates as well, but in the opposite direction. So the red line is going to represent how much, I don't know how to pronounce that word. Essentially, it represents how much the phytoplankton are able to absorb sunlight and produce energy from that sunlight. So this chemical that they have in them is the chemical that does the absorbing sunlight and producing energy from that sunlight, producing food from that sunlight. So the more of this chemical they have, the better. The less, the worse they are off. So we can see that as the temperature in the ocean increases, the productivity, or the amount of sunlight these phytoplankton are able to absorb, decreases. So as the temperature is going to go up over time, the amount of energy that these phytoplankton can absorb and produce is going to decrease. All right. Yeah, so this chemical here, this is what the phytoplankton are using to produce food, to live off of it, is how they get their energy. So as the water temperatures increase, they become less efficient at producing food, and therefore the population can decrease even more. So as the ocean temperatures increase, not only do the phytoplankton become less efficient, but they also don't get the nutrients they need. So the ocean is comprised of, you can think of it as almost layers. And when you have strong ocean currents, these layers mix, and you get nutrients that kind of passes through the layers. And this is what the phytoplankton need to live. So they need to have some sort of current, some sort of currents in the ocean that are that are feeding them new nutrients each year or each time they go to feed. Um, Without these strong currents, the phytoplankton are unable to get as much nutrients because the layers in the ocean aren't going to mix as well. And as the ocean temperatures increase, like we talked about last class, the currents also decrease. So ocean temperatures increase, currents decrease. So they're getting less nutrients because they don't have as strong currents. And this hits the larger phytoplankton harder. So the smaller phytoplankton don't need as many nutrients, so they can kind of adapt a bit better. But the larger phytoplankton, such as, if we look down here, such as the diatoms, are the ones that struggle the most. So if we look at the graph below, this looks at the relative abundance of diatoms, which is a larger breed of phytoplankton or a larger species of phytoplankton, and looks at how over time the population is going to decrease as CO2 emissions increase and as the oceans warm up. So on this graph here, if we look at the blue line again, this correlates to the right line, or the right y-axis, where we look at the concentration of CO2. And you may notice on this graph, we started year 0. That is, I believe this came out in 2018. So this is a prediction on how the future of phytoplankton will look. So as we go 140 years in the future, we can see that CO2 emissions are going to keep increasing, and they're going to increase faster and faster based on current trends. Now, a lot can happen in 140 years, but this is just a prediction. If we stay on that current path, this is what's going to happen. So the green line represents the relative abundance of diatoms, and you may notice this is not a smooth line. So what happens is they put all the information in a simulation, and the simulation is going to calculate at each given point in time how many these diatom phytoplankton are going to be around compared to other phytoplankton or compared to smaller phytoplankton. So there's going to be some fluctuation because that's what will happen in real life, and the model that we have will model what happens in real life and predict what will happen in the future based on that. So if it's a good model, this should be very accurate if we keep this trend. So what happens is we see that larger phytoplankton are going to decrease, and smaller phytoplankton will remain maybe about the same. They'll also decrease a little bit, but it's the larger phytoplankton that will decrease the most. And these are the ones that are fed on the most, that produce the most energy. So when you get larger phytoplankton disappearing, you get a large part of the food chain that's gone as well. So in about 140 years, they predict that the population will decrease by about 3%, which you may not think is huge, but this is relative to other phytoplankton. So not only is the population decreasing for the whole species, but the population of larger phytoplankton is also decreasing. So that 3% relative to other phytoplankton in 140 years turns out to be more like 40% when you consider the whole population is decreasing. All right, so I think this is just talking. So as these phytoplankton populations decrease, again, they're the main source of food for a lot of animals on the food chain. So when you remove kind of the base of the food chain, it's not going to be good for everybody that relies on the phytoplankton. So if you eat the phytoplankton, you're not going to have food. If you eat the fish that eat the phytoplankton, they're going to disappear, and you're also going to disappear. So without phytoplankton, the ecosystem in the ocean is not going to do well.